Okay, so we've got to talk about trigonometric equations now, which all that means is that when we have in the past solved something like this, right? Remember I would say, okay, you use an inverse sine because if you do this, right, then this is just theta and this is whatever that answer should be. It was kind of an overview of the process because if I say, okay, when is sine equal to 1/2, it is here at pi over 6, also known as 30 degrees. Okay, so your answer in radians would be pi over 6, but as we've gone over many times, sine is also equal to 1/2. It's equal to 1/2 at pi over 6. It's equal to 1/2 at this value here, which is at this angle here, which is pi over 6 plus a whole rotation, right? Which is 13 pi over 6, okay? So if you just keep adding 12 pi over 6, this is going to continue to be true. So this angle, I know it looks a little funny, but think about it, 25 pi over 6. All of these radian values are going to be 1/2 for sine of theta. So the way we write that fact for this example right here is you would say, here's what we started with, sine of theta equals 1/2. Okay, and so here's how we handle that for this example. Keep in mind that sine is also 1/2 right here, right? And that's 5 pi over 6, I believe. Okay, so when we're given this equation, the general solution that includes all of the possible answers, all the possible values for theta, for rotations in the positive and negative direction, that include both this and this, here and here, are written this way. You'll see either a k or an n, which will just represent a integer value. So pi over 6 plus, and I like to use n, but I have some examples with k, so we'll just use k, plus or minus k times 2 pi. I wrote it in the order I was saying it, but you'll see this, so pi over 6 plus or minus 2 pi k, right? Where k is 1, 2, 3, k is integers, okay? So this is an infinite set of solutions. The way you read it is theta for this equation equals pi over 6 plus 2 pi k, where k is any integer, and I have the plus or minus because it's saying, okay, we have this pi over 6, and then if I want to do the plus 2 pi, that'll be plus 1 full rotation will bring me back to the same spot that I'm at, right? So essentially what I'm doing is the plus 2 pi k is doing this. And then minus 2 pi k will be going the other direction. And the other solution over here, 5 pi over 6, works exactly the same way. So theta also equals 5 pi over 6 plus or minus 2 pi k, right? So the final answer for this would be theta equals pi over 6 plus 2 pi k, and theta equals 5 pi over 6 plus 2 pi k. And so that is just if you're given something that's sort of plain and barren like that, sine pi equals 1/2. If you get this, if it says solve this trig equation, and then you have this conditional right here, a condition that you're given, what theta is between 0 and 2 pi. Okay, if you're given a conditional, well then you only have to give them the solutions that occur between 0, there's a hidden pi here, but it means 0 pi, between 0 and 2 pi. And so those would only be the two that we found here, which is 5 pi over 6 and pi over 6. So given those conditions, given that restriction, well then theta just equals pi over 6. 5 pi over 6 is how I might write it. Or you might want to write this, or you might want to write this. Those should all be acceptable in a college level trig class. So that's the simplest type of trig equation, and it gets a little more complicated. Say you have this equation, 2 cosine theta minus 3 equals minus 5, and we're concerned with this range of thetas, right? So this is just like a regular algebra problem, but that has an angle in there. So it might be intimidating at first, but really all you're going to do is, add 3 here and add 3 here. So then you have that, divide both sides by 2, and you'll have -1. And then where is cosine of theta equal to -1? Right there, which is when theta is pi. And so I can write theta equals pi as a temporary solution. And then I might want to think, okay, do I need to list the infinite possible solutions to this? And no, the answer is I do not have to do that because they gave me this condition, which is satisfied only by this answer. Right, so if I do another one of those quickly, let's say we're given this equation, and it has this extra condition of that. It's another way of writing theta falls between those values. This means the same as this. Whoops, right? These mean the same thing. This says theta is equal to the values of theta that I'm looking at. Actually, I'm looking at x. Whoops, should be x. It says the values of x that I'm looking at include 0, are all of the possible values between 0 and 2 pi, and then stops at 2 pi, not including it. Okay? And that's why there's no line under that less than sign right there. And so same thing, we do subtract 1 to over here. So then we have 2 sine of x is equal to -1. Divide both sides by 2, -1/2. Where is it -1/2? Let's see. I know I have this, plus plus, minus plus, minus minus, and plus minus. So I'm going to say a negative sign value is going to be down here. Okay. And that'll be -1/2 is the short height, meaning it's here or here. Yeah, does that make sense? And again, the normal ticks that we use, the common ones are 30 degrees, 45, 60 degrees. And so I'm going to say, just by eyeballing my unit circle sketch, that this over here is pi plus another 30 degrees, which is pi over 6. So 6 pi over 6 right here, plus another pi over 6 is 7 pi over 6. And you can do the same thing over here, 2 pi, which is the same as 12 pi over 6. Yeah, my little sketch is getting bigger. 2 pi, which is the same as 12 pi over 6, minus this little bit of 30 degrees, which is the pi over 6. So 12 pi over 6 minus pi over 6, I'm going to get 11 pi over 6. So that tells me my answers for x are 7 pi over 6 and 11 pi over 6. Okay? What else do we want to look at? I know this has just been all examples so far, but there's a bunch of different types of trig equations. It's just any equation that you would normally think of in another math class, but with sine and cosine and tangent, cotangent, all those in it. So here's another example, right? Say we have this, which looks slightly more complicated because this is squared. -1 equals 0. And our theta is between 0 and 2 pi. Okay, so it looks like we're going to have this, because I moved this -1 over there. And we're going to have this, right? And because I divide both sides by 2. And then we'll have square rooting both of these. I'll write it. Okay, when you do this, you get sine of theta over here. And you get the square root of the top over the square root of the bottom, which we don't need to write the square root over the 1. And also, I touched on this very briefly in one of the videos, but just make sure you know that this value right here, whenever you see it, it is the same as this. Root 2 over 2 is equal to 1 over root 2 itself. So I'm going to say, okay, that's my answer. And then between 0 and 2 pi, which means that I'm going to go on my unit circle and only look in one rotation. Where is it root 2 over 2? Positive. It's here at 45 degrees / pi over 4. And it's here at 3 pi over 4. We're aware of that. But there's one thing that I did not do, which is a drill that you should constantly be doing and have it stuck in your head. When I did this square root and this square root, you always have to remember to put this symbol right here. This is some mathematical rigor that will pay off. Absolutely. It even deserves a little bit of a highlighter because I just forgot it in this scenario, and it happens. So that means it would carry all the way here. Okay, so this is where the coordinate is root 2 over 2, root 2 over 2, and root 2 over 2, root 2 over 2. But then also negative root 2 over 2, negative root 2 over 2, and positive root 2 over 2, negative root 2 over 2. So we're including our plus or minus root 2 over 2 pi values. So we have to count 1, 2, 3, 4 solutions. So pi over 4, 2 pi over 3 pi over 4, 5 pi over 4, and 7 pi over 4 are all solutions. So theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, good. So that's showing that here's how we started. The solutions to this equation on this interval that I can denote as this, or by the root 2 over 2 over here version, right? Include these 4 solutions. 1, 2, 3, 4. And so the key to this problem was if you ever have this, x squared is equal to a, and you want to know what x is, then make sure you do this. Plus or minus the square root of the thing on the other side of the equation. Make sure, because that's how you get the other two solutions that are down here. Which, again, you notice they are within the interval that is asked for, so they need to be included. They come out of this problem because there's a sine squared. In general, every sine of theta is going to have 2 solutions on one rotation, right? As we just did, sine of theta is 1/2. Well, every sine will have 2 solutions, one here and one here, because it's positive 1/2. While every sine squared is going to have 4 solutions, because that squared, when you do the algebra, is going to result in a theta, which right here is equal to, when you undo the square with the square root, it's going to equal plus or minus this value. Okay. And we'll do an example for tangent, because remember, one period of tangent is 0 to pi, right? So it's slightly different, but we'll go over the infinite solutions for tangent of theta or tangent of x. So let's do 2 times tangent x plus 3 is equal to 5 plus tangent x, and our interval is this. Okay, so things just got a little bit interesting, right? First, we start by doing algebra. 2 tangent of x, you multiply this by this. 2 tangent of x plus 6, multiply the 2 by this 3, equals 5 plus simply tangent of x. And so more algebra says let's subtract the 6 here. Alright, see I moved these whole numbers over to the right, and all I did was switch the position of these two here. So next thing is to subtract this tangent and put it over here. So minus 1 tangent. This is a hidden 1 here. So tangent of x equals minus 1. All right. And then the question is, when does tangent of x equal -1 unit circle time? I know that tangent of x is sine of x over cosine of x, right? We're always going right there when we get the chance. Sorry if I'm a little sloppy there. All right. So tangent of x is sine of x over cosine of x. And that is 1 at these 45s, as we should be quite familiar with now. Okay. And when is it negative, though? It is when one of the two is negative, but not both, right? So when it's like this, or when it's like this, and that occurs, here are our quadrants, plus plus, minus plus, minus minus, and plus minus. So it occurs here and here, right? Makes sense? So sine over cosine is going to be -1. Sine over cosine is going to be -1. So we write x equals 3 pi over 4, comma 7 pi over 4. Done. And that is on this interval 0 to 2 pi. Now, say they didn't give us this condition. They just want to know, solve for all the x's possible. Well, then all we would do is question ourselves about when do these points occur given an infinite amount of rotations in the positive direction, counterclockwise, and an infinite amount of rotations in the negative direction, clockwise, right? So, general solution, which means no conditions given, would be this x equals, so when does it occur? Okay, it occurs at 3 pi over 4, then again at 7 pi over 4. So you're adding a 4 pi over 4 to get to that solution, right? So that's plus 4 pi over 4, okay? So 7 pi over 4. And then that's just a pi right there. That's equal to pi. So then we have this rotation, pi over 4 radians rotated. This rotation, you can see it visually. That's the first solution is found. Then a full 180 degrees is added to get you this halfway around the circle to the next solution. To get the next solution is another pi around the circle. So you could keep writing it like this. You could say it's 7 pi over 4 plus you add 4 to this, right? And it'll just be 11 pi over 4. And then add another 4, which would be 15 pi over 4. You could keep doing that and, your arm would get really tired. Your wrist would definitely lock up. So, well, these aren't being added, I guess. These are just solutions. Sorry. But to save a lot of time and energy, we, instead of writing out an infinite number of solutions, we just say it's 3 pi over 4, which is the first solution, plus pi times k, which, like I said, you'll either see n or k here. I wrote pi times k, but again, I should write it the way you'll most likely see it. So 3 pi over 4 plus k pi, where k is 1, 2, 3. So instead of writing the dot, dot, dot here, I'm saying this is for all integers you can imagine from 1 to infinity. And once again, don't forget, it's also true if you go the other direction, right? This is 3 pi over 4. If you subtract pi radians from that, that means you're going around the circle this direction, okay? Well, now you have this value here, negative pi over 4. So this solution we've written here includes 3 pi over 4, 7 pi over 4, 11 pi over 4, okay? And it also includes this direction, minus pi over 4, minus 5 pi over 4, minus 9 pi over 4, okay? So this is an infinite set of solutions. You'll notice here too that it's pi for tangent. The same goes for cotangent rather than 2 pi as it was with our infinite solution of a problem with sine in it. Where did I write that? Right? For sine, it's going to be 2 pi increments. And then for tangent and cotangent, it's going to be pi increments. And that's because of the period of tangent, cotangent, which are just a single pi, as opposed to the 2 pi of sine and cosine. And the one other thing I wanted to talk about is solving using a calculator. So I'm going to pull up the calculator right now. So let's say use calculator to solve this equation. Secant of theta equals -4. Okay, so first thing, it's algebra time. So we use the identity secant is equal to 1 over cosine. And you don't have to do anything to the right because we didn't technically do anything to the left. It's an identity. That's sort of what identity means, is when you use it in algebra, you don't actually need to change the other side of the equality because it doesn't change the equation. So this, again, we can flip both. So I'll do this, right? Remember, this just means the reciprocal, because in trig, inverse functions are a specific thing. But you could just eyeball this problem from the beginning and say, okay, secant of theta is -4, then cosine of theta must be -1 over 4, right? But just want to show the steps. So first I did some algebra. This statement is true. Now we're going to practice using the calculator by saying, okay, if I want theta, then it's going to be inverse cosine of this number, which we can do here. We'll make sure we're in radians, which we are. So we'll do shift inverse cosine of this negative sign. Remember not to use subtraction, but negative sign, 1 over 4. And then the calculator will tell us 1.823-ish, approximate. And since we're working with cosine, a period is 2 pi. So for our general solution, which has infinite answers, we will say it's 1.823 plus or minus 2 pi, but we're going to continue to use decimals. So 2 pi is 6.28 radians. You can double check it by just typing 2 pi, okay, and times that integer k. So this reads the same as the way we did it the first time, right? 2 pi k. But I just like to have, actually, to be more exact, I think it's better to say 2 pi k. So we'll go with that. This is more true than what I had written. I just wanted to keep it in decimals, but really this is more correct. So just to do another example, say we have this trig equation, okay? Well, that is theta equals inverse cosine of -0.2. So let's say inverse cosine of -0.2. So it equals about 1.772. Okay, plus or minus your period of cosine times arbitrary integer. So this is for all of the integers. 1, 2, 3, ... Didn't write on the last one. Sometimes people just leave it out, but it should be stated what you're talking about, where k is some integer. Okay, cool. All right, so let's do some other problems as well. All right, let's try this one. I should have made the font bigger. 2 sine of theta plus 3 equals 2. 2 sine of theta also equals -1. Sine of theta equals -1/2. Might have already done this one, so I'm going to write it quickly. Where is sine negative? Well, it's down here. This is where the y values are negative, is down here. So if it's 1/2, that means it's the short height. So here, this is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. This is 7 pi over 6. And then we have this, we have the 12 pi over 6 here minus the pi over 6. So 11 pi over 6. That means on this interval, theta equals 7 pi over 6 and 11 pi over 6. Here we'll have Move that 1 over here. Minus cosine of theta is going to equal 1/2 minus 1. We want to get these to be the same denominator, so I'll do 1/2 minus 2/2, which is going to be a negative 1/2. So negative cosine of theta equals negative 1/2, which means cosine of theta, we can just get rid of these. Cosine of theta equals 1/2. Where are the x's positive? Over here. Okay, where's cosine 1/2? Well, that's when the x distance is shorter, so that's here and here. And these values are pi over 3 and this 2 pi. And then this other point here, which I know that this is pi over 2, 3 pi over 2, right? And so this little bit right here is another 30 degrees, aka pi over 6. So 3 pi over 2 plus pi over 6, well, that's the same as 9 pi over 6, right? Because I'm trying to get the same denominator, I'm multiplying this by 3 over 3. 9 pi over 6 plus pi over 6, which is 10 pi over 6, which is 5 pi over 3. Oh, and I remember what we talked about, I did not check. They don't define an interval for me to use. So, though it is true that it's pi over 3 and 5 pi over 3, my final answer will be theta equals pi over 3. And I can even use this as sort of a hack, because it's going to be this solution and this solution, then all rotations where you end up on this point of the circle, either in the positive or negative direction of rotation. So it's pi over 3 plus a full rotation, which will be 2 pi k, where k is, plus or minus 2 pi k, where k is some integers, all of them. And theta equals 5 pi over 3 plus 2 pi k, plus or minus. We're gonna get that highlighter out to remind me and my viewers, right? Where k is these positive integers, all of them, okay? So we did a general solution there. This also has no interval, so we're gonna do a general solution. I will start by adding the 3 over there. 5 cosecant of theta equals positive 5. Divide both sides by 5. Where does cosecant equal 1? Well, it's where sine of theta equals 1 over 1. I kind of skipped a step. What I'm saying is 1 over sine of theta equals 1. When is that true? It's also when cosecant equals 1. So when is sine of theta equal to 1? It's right there. That's a height of 1. So sine of theta is 1 here, and that's at pi over 2. And so our infinite solution set is going to be pi over 2 plus or minus 2 pi, because we were talking about sine, k, where k is a bunch of positive integers, an infinite amount of them, actually. All right, let's keep going. Right off the bat here, we have to do a square root on the 1/3 so that we can know tangent of theta is equal to the square root of 1/3, which another way of writing that is the square root of, which is another way of saying 1 over root 3. And so, plus or minus, never forget. Okay. Where is the solution? 1 over root 3. This is one of those where you may memorize the solutions for sine and cosine, right? The coordinates on the circle. But are you going to remember every angle for the common angles for tangent? Maybe not. So rather than do it by hand, let's ask the calculator. Okay, calculator. Also, recall that another way of writing this is, of course, theta is equal to inverse tangent of square of 1 over root 3. I'll do the same thing for the negative. So this is what I'm going to ask the calculator. 1 over square root of 3, okay? It's when we're around 0.52 radians, but I would like to maybe know degrees approximately, just for my interest. 30 degrees. So that's what they were getting at. Did I not try that one? At 30 degrees, you have 1/2 I just wanted to try it in degrees because, so this is this theta, this solution, and that's approximate 30 degrees. So I could have figured that out if I just thought about it. At 30 degrees, you have x is √3/2 and y is 1/2. And you put one over the other. In tangent, you put 1/2 over √3/2. That's going to be 1/2 times 2/√3, which you can't cancel those 2's, gives you 1/√3. So it's true at theta equals 30 degrees. And so since it comes out to just a round number of degrees, even though it's not said, the problem just gives you this. You're probably going to put your answer in degrees. Otherwise, the answer is going to be 0.523598 radians. But 30 degrees just looks cleaner. So this occurs at 30 degrees. And then the negative 1/√3 is, again, going to be when sine over cosine is negative, which is, if we look at our quadrants, positive, positive, negative, positive, negative, negative, positive, negative, positive, negative. So we see that one solution occurs at 30 degrees, and since we're working with tangent, remember the period is 1 pi. So another solution I know is right here, pi/6, and then 7 pi/6, okay? And another solution, since we also want to consider the negative solutions, we think, okay, it's going to also occur where we have 1/2 over √3/2, right, in our tangent, which is y/x. So where else is y equal to 1/2? It's over here, where y equals to 1/2, where x equals √3/2. It's over here. And where else does y equal 1/2 and x equal √3/2? But they are positive, negative. Well, that's going to be right here. So if this question were to say, right, from 0 to 2 pi, if it were to say that, then these would be our four solutions: pi/6, 5 pi/6, 7 pi/6, and 11 pi/6 would be our four solutions. But once again, we have no conditions given. So we want to write it in the form of infinite solutions, meaning theta is going to equal pi/6 plus or minus pi times k, and theta is going to equal, the first time our negative value here occurs, this is right, the answer here is negative 1/√3, because it's a negative x and a positive y. So the first time our negative one occurs is at 5 pi/6 plus or minus pi times k. This gives all the set of solutions that are integer multiples of pi distance away from these points. So one here, again occurring here after another rotation, again occurring here, right? So that's going to be your set of infinite solutions for that problem. So when we looked at this plus or minus, we considered this position on the unit circle, which is where x, y equals √3/2 and 1/2. Because tangent equals sine over cosine, and when you put this sine or y value over the x, you get 1/√3, okay? Then since it's tangent that we're dealing with, we add 1 pi, half circle, to get the next solution. We add 1 pi, another half circle, to get the next solution, and there's an infinite number of solutions, so you keep adding a single pi, and then that's what gives us plus 1/√3. And then, like I said, when we did the algebra and we got out a square root that triggered this plus minus, that means we also need to know, that means we are also interested in the solutions where the y is positive and the x is negative, or the y is negative and the x is positive, because then when we apply this, we get a, say we're starting with this 5 pi/6, we get a positive y over a negative x, right? Because the coordinate here is negative root 3 over 2, 1/2. That is the coordinate here. When I put the y over the x, this answer is now going to give the negative version. Because you have a positive over a negative, you result in a negative. Then what we did was we said, okay, that's the first negative 1 over root 3 solution. I would like to add a single pi radians to get to the next one, right? It occurs here again. This is the value, or the coordinates there are this flipped, positive root 3 over 2 and negative 1/2, right? So when we flip this, it's also going to yield a negative 1 over root 3. So that does add up, but really we could have just added a pi because we know we're working with tangent, which has a period of pi. And then we do that with an infinite number of solutions as we continue to add pi, add pi, add pi. And that's how we got this. The first solution, where the answer was negative 1 over root 3, plus or minus this increment of pi times integer k. And that should be good for that one. Okay, this one says solve each equation, give a general formula for all the solutions, and list 6 possible solutions out of the infinite ones. I'm not going to do this one because we've just done it, I think, like 3 times now, but we can do it with this. If tangent of theta equals negative root 3 over 3, that means sine of theta over cosine of theta equal root 3 over 3. Where does that occur? Let's find out. Thank you, handy dandy calculator. Root 3 over 3. Alright, it occurs at minus 30 degrees. So theta equals minus 30 degrees. That is here, negative rotation around the circle. So clockwise rotation this way around the circle, which is equal to minus pi over 6. And so we want to write the general solution. We will say theta equals negative pi over 6 plus or minus pi, because we're working with tangent, times k, where k is all these integers. So that's going to be the general solution. And then they want 6 out of us. So I know that if I add pi to this, it's going to end up over here. And if I add pi to that, it's going to end up over here. So all the solutions are just this point, this point, this point, this point, adding a bunch of pi's, right? So I can add or subtract pi over 6 from, add or subtract pi from pi over 6 to get each solution. So I'll say, okay, one of the solutions I'll write out here is negative pi over 6, and then I'll add a amount pi, which is 6 pi over 6, and negative pi over 6 plus 6 pi over 6 is 5 pi over 6, which just happens to be this point on the unit circle once you've gone in the positive direction from 0. So 5 pi over 6, adding another pi to that is 6 pi over 6, so 11 pi over 6. I'll add one more and just say 6 pi over 6 again. It'll be 17 pi over 6, okay? And then if I subtract 6 pi over 6, well, we have negative 1 pi over 6 minus 6 pi over 6 is going to be negative 7 pi over 6. Then if I subtract another 6 pi over 6, we'll have minus 13 pi over 6. And 1, 2, 3, 4, 5, 6 solutions. That's all you got to do for that. So I can write here that at these points we have minus pi over 6, and then this is 5 pi over 6, but this point is also negative 7 pi over 6. This point is also, and this point is also negative 13 pi over 6, and also 11 pi over 6, and then this point here is also 17 pi over 6, right? So it's just a matter of how many rotations you do. So this first arrow is minus pi over 6, then subtracting a single pi over 6 brings us here, subtracting a single pi brings us here, subtracting another brings us there, as opposed to adding a pi brings us here, adding another pi brings us there, right? So all of our solutions are at this point on the circle. They're just different rotations, greater and greater or lesser and lesser rotations. Okay, I don't know if I gave an example of this. I don't know if I lectured this or if I'm just going straight to the examples here, but cosine of 2 pi equals minus 1/2. One way to do this is, again, just from inspection, I'm going to say, okay, cosine of 2 times some angle theta gives minus 1/2 on the unit circle, right? Well, on the unit circle, cosine of theta is minus 1/2 at, right, we have positive and negative x's. So a negative x is 1/2. It's short, so it's like right here at, that's pi over 2 plus pi over 6. So that's 4 pi over 6, which equals 2 pi over 3. So at 2 pi over 3, cosine is negative 1/2. But it's asking about when cosine of double the angle of theta equals that. So all you really have to do is cut this in half. 2 pi over 3 divided by 2, also known as cutting it in half, is 2 pi over 6, which is equal to pi over 3. So, right, when is cosine of 2 theta equal to minus 1/2? It is when theta, just a moment. Well, cosine of theta equals 1 minus 1/2 when theta equals 2 pi over 3, comma. So cosine of 2 theta equals minus 1/2 when 2 times theta equals 2 pi over 3. I hope this makes sense so far. And that is when theta equals 2 pi over 6, which equals pi over 3, right? I thought I'd write it in words to be more helpful. I hope it doesn't actually make it more confusing, but there you go. Let me add a page here. So cosine of 2 theta equals minus 1/2 cosine of 2 times 2 pi over 3 equals minus 1/2. Right, this is my check. I'm doing my check. 2 times pi over 3 equals minus 1/2. Cosine of 2 pi over 3 equals minus 1/2 right here, right? Okay. And there's also the double angle formula, double angle identity, which makes this easier to work with, but I want to, again, do all the identities in the next video, and there's just multiple ways to solve each of these. This is, again, by inspection and just identifying what does it mean for 2 theta to be in the argument. Okay, so I have the calculator pulled up. We're going to do sine of theta equals 0.4. Remember, this is, you can do inverse here. We have this interval, so theta is the inverse sine of 0.4. It tells us to use a calculator, so we're allowed. Let's do that. Shift sine gives us inverse sine, 0.4. I think it's going to give my answer in degrees, but let me do radian instead. Okay, same thing, but in radians. So theta equals, nope, theta equals approximately 0.412 if I round. 3 decimal places is always nice. Oh, it says to round to 2 decimals, so we'll do that instead. So let's do the same thing, calculator, but with tan of theta. So I'm going to write out inverse tangent of 5 equals theta, and we are interested in theta. So we'll do inverse tangent of 5 in the calculator. Theta is approximately 1.37, say 3 decimals or 2 decimals, okay. 1.37, which it's, so at 1.37 rads is, let's see, this is 3.4, this is 1, or sorry, no, 1 radian is here. I lied last time. It would be like here. It's okay. It's just a sketch. It's okay if your sketch is kind of goofy and wrong, as long as you're sketching something. Okay, 1.37 radians is here, so. Alright, last one. Last 2 problems, I should say. Solve this on this interval. We have to pay attention to that. Okay, so the first thought I have here is I'm going to say, okay, this is 2 cosine squared theta, and I can subtract this cosine from both sides. So it'll be 2 times cosine squared theta is equal to negative cosine of theta. I can divide both sides of this by cosine. That's allowed. So that will leave this side saying 2 cosine of theta equals -1. And then divide both of these by 2 will give us cosine of theta equals -1/2. So you see this original problem looks kind of scary, but it's just a little algebra. And we've done this specific solution a few times now with a negative x. That's this side over here. And it's 1/2, so it's a short x. So it's going to be here and here. Since we're on this interval, we don't need to give the infinite number of solutions. We just need to talk about this point and this point. So theta equals, again, remember this is pi over 2. I'm adding another pi over 6 to get here. This is just stuff I have in the back of my head off the unit circle. You can check by using your unit circle or whatever it means. But pi over 2 plus pi over 6 is 3 pi over 6 plus 1 pi over 6, which is 4 pi over 6, which is 2/3 pi, or 2 pi over 3. So one of the solutions is at 2 pi over 3 right here. And the other's down here, but I'm just going to first put this 2 pi over 3 oh, we're not doing infinite solutions. We're not doing infinite solutions. So first answer is at 2 pi over 3, then the second one is down here next to, what is this, pi over 2, 2 pi over 2, 3 pi over 2. So this point is 3 pi over 2, and then this point is pi over 6 short of pi over 2. So another thing I can do, just a little bit of quick math, unless you have a unit circle right in front of you. Another trick is to do 3 pi over 2 minus pi over 6, which is 3 pi, which is equivalent to 9 pi over 6 minus pi over 6, which is 8 pi over 6, which reduces to 4 pi over 3. Okay? And so that is your complete answer. And this is the last one. Did I do a square root? I didn't do a square root here, which would probably address... Did I do a square root? No, I didn't. I just divided. That's interesting. I didn't actually take a square root, so I didn't get the plus minus. But it's still order 2, so that's how you know it's going to have 2 solutions. Order 2, 2 solutions in one rotation. If you have infinite number of solutions, or it's from 0 to 4 pi, then it's 2 solutions per rotation. So we have this problem. We'll say, okay, right off the bat, let's put that 1 over there. Sine squared of theta is 1. Sine of theta then is the square root of 1, which is 1. But we're going to put plus or minus to remind us. So theta is inverse sine of 1 and inverse sine of -1. Or we can just say, inspect the unit circle. Say, okay, when is sine of theta 1? It is at pi over 2. And when is sine of theta -1? It is at, what did I say, 3 pi over 2. So theta equals pi over 2, comma 3 pi over 2. That's all you got to do. Order 2, 2 solutions. All right. Hope that helps. See you in the next one.